What I'd like to do is now work through how you would use these limiting reactant problems, the results, to figure out what the molarity is of your remaining ions that are in solution. So for the question D, it asks what's the concentration of the molarity of the remaining ions. The first thing we need to do is recognize which ions are still remaining in the solution. So I have here an image of just a random number of leads, nitrates, sodiums, and sulfates. And looking at our equation, it looks as if all the lead sulfate has bonded together, Pb and SO4. And so we're actually left with a lot of PbSO4. Now, going back to what we have is we have to ask ourselves, did we have any excess of these ions? So we're going to look at each set of chemical formulas individually, ask ourselves, do we have any excess of that ion, and would it be found in the solution? So I'll start off with Pb. You notice over here for Pb that we did have more than enough Pb, and because of that, that lead, not all of it actually formed to PbSO4. Some of it is still floating around as extra. Okay, so we know that we have a concentration of Pb plus 2 ions, and I know that because I know I was left with excess reactant. So how much do I have of that? Well, that's relatively easy to identify. Remember, when I'm looking for concentrations or molarity, it is moles over liters. And we need to spend some time looking at, well, how many liters total is it that we now have in that beaker? And I poured in 1.25 liters of PbNO3 too, and then I poured in 2 liters of Na2SO4. That means that I have, for lead, I had a total solution of 2 liters plus the 1.25 liters, which is the same thing as saying, and I'll go ahead and erase that to make it a little bit cleaner. It's the same thing as saying that I have a total of 3.25 liters of solution. So the next part is, well, what concentration of that is going to be Pb? And do you notice how we have an invisible one here? And it looks like we have, for that reason, the number of moles that I have left over is appropriate, 0.0125 moles of just Pb is what I have, and this will then allow us to calculate our molarity. So in this case, I take my 0.0125 divided by 3.25, and my answer is 0.004 molar solution of just Pb is left over. Remember, some of that became a solid, but we still had leftovers. So we need to now talk about what else we have. So the other one would be SO4. So looking at SO4 over here, it looks like none of the SO4 was left over. It all reacted to be PbSO4, so we do not need to solve for the solubility, or excuse me, the molarity of SO4 because it is 0 molar. So SO4 minus 2 has 0 molarity because none of it was left over. All right, now we need to take a look at the other ions, particularly the spectator ions. All right, so we know we have still some Na plus and NO3 floating around. So take a look over here. On this side over here, it tells me that I have 0.1 molar of NaNO3. And by saying that, by saying you have 0.1 molar of NaNO3, It's like saying that we have 0.1, excuse me, and that's not molar. It should be moles. Let me change that. So it tells me I produced 0.1 mole of NaNO3, which is the same thing as saying that I have produced 0.1 mole of Na and 0.1 mole of NO3. Now, let's say, for example, I happen to have a formula that instead says Na2SO4. In that case, I would say, oh, I have 0.1 mole of SO4, and because of this subscript 2 for this cation, I would double that amount to be 0.2 moles of Na2. So just as a reminder that your chemical formulas, a number of cations and anions that are indicated would then you'd actually reflect that in the actual number of moles. But in this case, we don't need to do that, so I'm going to erase my example because it does not apply at all. That was just completely made up. And because there's a 1 here and a 1 here, I know that I have 1 mole of each. Now the thing is that for NO3, so let's work with Na first. Did I have any Na left over from my original? And the answer is no. So for Na, that's quite simple. I started with 0.1 moles of Na. And I had nothing left over, so it all formed into this NaNO3, which of course is still dissolved, and they are floating around in 3.25 liters of solution. So in that case, I'm going to do my division, 0.1 divided by 3.25, and that gives me the answer of 0.031 molar solution of Na plus ions. The one that gets a little bit more challenging is this NO3. So with NO3, do you notice that you still have NO3 left over? So we definitely know that we need to deal with the NO3 that's here, and in addition to the NO3 that never actually reacted. So for NO3, I take my value that I have, so I know that I have ended with 0.1 moles of NO3, but I can't forget that still some of that additional NO3 from the PB NO3 just never was involved. We had extra, and we have to include that extra. And so I take this value, and do you see, because of this subscript over here, it means I have 2 moles worth of this, which would work out to be, so 0.0125 moles times 2. The reason I'm doing this times 2 is because of this subscript number. So that works out to be 0.025. So that means I have a total of, if I were to rewrite that, I have a total of 0.125 moles of NO3 over 3.25 liters. And that molarity is 0.04 molar NO3 minus. Okay, so just as a quick review, in order to find the concentration of each of these free ions, the first step and the easiest step is to add your volumes together. These volumes will always be the ones that are on the bottom for your liters. The next step is taking a look and seeing which material was all used up and which one was left over. We know that the SO4 was all used up to form a solid, and because it formed a solid, it is not floating around as an ion, so that's why we do not do that calculation. I could tell that we did have some lead left over that did not bond, and the reason I know that is because I still have excess reactant. So seeing that there is a subscript of 1, I know that I can just take its pure molar quantity and put it over my liters. With the sodium and nitrate, with the sodium, I could tell that sodium was essentially all placed into the equation, into the beaker. None of it reacted. We know through our BCA table that we had 0.1 moles of Na that went into the solution, and we'll put that over the entire volume. And for the Na, for the NO3, the NO3 is a little bit more complicated because we know that these pseudo can connect. We're going to take the 0.1 mole that would have connected with the NO3 if it had enough intermolecular forces, but we also are going to put in the extra NO3 that was left over from from the excess reactant and add those. So for that reason, I'm going to add that molarity. Do not forget, those moles. Don't forget that because of this subscript 2, you have two moles of whatever quantity this is, or 2 times the moles, okay? And this one is by far the most challenging.